Welcome back. In this lesson, we're going to use the perpendicular bisector theorem to solve these two problems. First, let's review what is called a perpendicular bisector. Perpendicular bisector can be a line segment, can be a ray, can be a line, can be a plane. This has to be perpendicular to the line segment at its midpoint. Then it will be called perpendicular bisector. All right, let's look at our example. We have a line segment AB. I'm going to take the midpoint. I'm going to call it C. And then tick mark tells us C is a midpoint. Point C bisected segment AB. Now, I'm going to create a line pass through this midpoint, also perpendicular to segment AB. I'm going to take another point on this line. I'm going to call it O. Now, line OC or line CO is a perpendicular bisector of segment AB. You see, it is perpendicular to segment AB, so perpendicular. Also bisect. Why? Because it passes through this midpoint C. Now, that's the definition and also help us how to find a perpendicular bisector. All right, we're going to connect OA and OB. Now we have a segment OA and a segment OB. Perpendicular bisector theorem says, in a plane, if a point is on the perpendicular bisector of segment, then it is equidistant from the endpoint of this segment. Now, so O is here. Let me trace this O. Or I can rewrite here, right down here. See if I can erase this, make it better. All right. You see point O is on the perpendicular bisector. By this theorem, it says OA and OB gonna have the same distance. So OA equals OB. Now that you understand this perpendicular bisector definition and theorem, let's solve this problem. The first one. You see the first one gives us one tick mark. That means AS and ST have the same distance. That means S is a midpoint. And also look here, you have a 90-degree symbol, so which means segment CS is perpendicular to segment AT. So we have a bisect and we have perpendicular, which means segment CS is indeed the perpendicular bisector. Now, by perpendicular bisector theorem, we know CA and CT gonna have the same distance. So CA and CT have the same distance. We can set up as 5x minus 8 equals 2x. Let's solve for x. So we have 5x minus 8 equals 2x. We're going to minus 2x each side. We're going to plus 8 each side. I'm going to write down plus 8 a little bit lower for you. All right, plus 8. Now we have 3x is 8 and x is 8 over 3. You can leave it here. You can say x is 2 and 2 over 3. 2 and 2/3. All right, let's look at the next question. Next question, we also know by looking at the symbol, we also know it is a perpendicular bisector. Why is that? Let's look at this. You have one tick mark. It tells us, okay, it bisects this line segment DG. OS bisect segment DG. All right, let's look at this little symbol here. All right, that's a 90-degree perpendicular, which means we got a perpendicular. See, perpendicular bisector, which means OS is perpendicular bisector of segment DG. Now, let's go back and revisit this one. Perpendicular bisector theorem says what? In a plane, If a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment, which means we can say OD and OG have the same distance. And we can set it up right here. It's a little bit crowded, but it's okay. We're going to write down here. And then we're going to solve it. 11x minus 9 equals 6x plus 11. And please pause this video, see if you can solve this on your own. And I run out of space, so I'm going to directly write down what I found x is 4. Okay,